Hello, everyone. In this video, I will give a few explanations about statics lab. We'll use, again, the bicycle, the weights here, and of course, I'll use the mat to not hurt myself. Here is the scenario. If you apply a force on the pedal axis, the back wheel will rotate. And the question is, how much force should I apply on the back wheel in order for the entire system to stay in equilibrium, so the system to be static? So let's put the masses on the axis. First of all, the gears are set in the way that the chain goes on the smallest gear in front and on the next to the largest gear in the back. And the chain is not extendable. This is a very important fact when you analyze the forces applied to the system. So I'm going back to the question. If I apply a force here, what force should I apply on the back wheel so the system is at rest or in equilibrium? There are two ways how to calculate that. One is theoretical. So I would like you to start writing down some equations considering the forces applied to the system, starting with the force applied by the weights right here, and then go through the chain to the force applied on the back wheel, probably right here. And I'll set up everything after I explain. So after you calculate that theoretically, we'll measure that using the force sensor. But before I measure with the force sensor, let me show you a couple of things. The force sensor has a switcher which sets the sensor to the 10 newtons or 50 newtons. Should I set that to the 10 newtons or 50 newtons? This depends on the force that you'll find theoretically. So stop the video for a moment, complete the calculations, and then come back and complete the everything else and get the information from what we will have with the motion sensor. I hope that you'll get the value of the force greater than 10 newtons. So having that greater than 10 will make us set the force sensor to 50 newtons. So this is the first thing that we have to keep in mind. The second thing, where are the forces applied? On this setup, on the first synthesis question, the masses will be we'll apply a force here at the axis, the pedal axis. We want the masses to be in the system. And this masses, the arm will stay horizontally, which means that the angle between the crank arm and the vertical direction is 90 degrees. So as I see, I'm using the vertical axis or the vertical direction as a reference axis to measure some angles here. So the first one, this is horizontal. And then I'll put the force sensor on the back. And in this case, the force sensor will be connected to the back wheel right above the axis. So right here, which means that this point here creates with the vertical axis an angle 0 degrees. Okay, so again, the point is to keep this system in equilibrium. Okay, to make sure that the crank arm is horizontal, I will look at the bulb here at the level. and it looks like it's a little more because this is not above the axis. Okay. Still not above the axis. One more time. And I think that we're pretty good here. Then, at this moment, I'll start the Logger Pro and measure the force applied to the system. As you can see, the force applied is constant all the time. Use statistics to find the value of the force and compare this force found experimentally with the force that you found theoretically, and do a comparison. We'll give you the value of the mass of the weights. We'll give you the length of the crank arm, and you have all the information about the gear's radius in the appendix in the manual.